Welcome to another GCBASIC tutorial for the PIC18FxQ35 chip family. This is part 3 using the ADC, analog to digital converter. Getting excited. So please like and subscribe, like the video and subscribe to the channel. Okay, so this is number 3, LED to represent the value of an ADC. So we're not going to show the actual the data values yet. We'll do that shortly in a later video, but what we're going to do is just show you how to use a read and how to display values of that read using the LEDs. It's just a really good method to see how things work. So compiler supports these Q35 chips, and it also supports about 1400. So this code that we're generating now will work on majority of chips. It's not specific to the Q35, but I'm using it for the Q35 validation process and for these tutorials. So what am I using? I'm using an old PICDEM Plus board. It's got many different features, and what we're going to be using is number 6, which is a 5K pot for devices with analog inputs. So that is connected into the microcontroller, and we have 4 LEDs connected on port B. So that's number 6 and number 9. So here's the circuit, and the circuit's quite useful. It's a good reference for anyone looking at how this works, because it's got a full set of circuit diagrams, and that's in the PDF that's associated up on GitHub. We put it on GitHub alongside this project. So what we're going to do, we're going to configure the analog to digital. We're going to run a conversion. Then we're going to read the analog voltage that's been controlled by that pot, that little 5K pot, and display those results on an LED. Really quite simple. Lots of registers involved, but that's all masked. The complexity of that is all masked by GCBASIC. So zooming in on what we're attached to, let's get the right-hand one done. LEDs through suitable resistors are connected to port RB1 to RB3. 4 resistors, 4 LEDs. And on the left-hand side, we've got connected to RA0. It has a current limiting resistor, and then it has a potentiometer, a 5K resistor. And as I change that, as I change the voltage on that, or the position of the LED, the potentiometer, the LEDs will react. And how will they react? Well, what's going to happen is that GCBASIC will initialize the chip. We're going to create a variable to store the ADC results, and we're going to read the ADC and put that inside of that variable. Now, GCBASIC makes it very easy to read an ADC. Hand on my heart, is it fully optimized? Absolutely not. Is it good? Absolutely right. So it makes it easy. And for the beginner, it might be the best way. But if you want to look for code optimization and performance, yeah, just take what we've done and just hand crank it yourself. So a ReadADC as a function returns a value of 0 to 255. That's the limit of a byte, sorry, 8 bits. Then we're going to set the LEDs and we're going to do it all again. So here's the high level view. Initialize, create a variable. We're going to read an ADC. And then if the value is less than 50, set no LEDs. Greater between 50 and 100, set 1. Between 100 and 150, set 2. Between 150, set 3. And above that, set 4. So we're going to introduce quite a bit of new logic as well. So I'm assuming that you've installed the GCBASIC software, the IDE called GCStudio. You've installed your programming software. You've got a Q35 attached. You have 4 LEDs operating, and you have the pot connected. I'm assuming those things as per the circuit diagram. Now, I just changed the port configuration there because I was using the wrong one. But what I've got is port A an ADC, and 4 LEDs as previously stated. So, workshop, read the ADCs, use a byte variable, some simple logic. Let's get started. Press Windows, and I'm assuming that you've got GCStudio installed. So GCS will bring up GCStudio, and there we go. We get the banner up, and then we get this menu. So let's have a little zoom in on that. What else should I show you in here whilst we're in here again? The spanner. Now, your update channel will be set to mainstream. Mine is set to nothing because I have a special build, okay? You can choose different IDEs. You can choose the old SynWrite. GC Code is recommended. You could use GC Graphical or VC Code, and we'll do different. We'll show you why these have different benefits. But SynWrite, please don't use it. It's just not. We don't maintain it. VS Code looks just like the IDE that we're going to be using. However, you can do some more stuff like the AI, and I'll do a different, completely set of videos on that. Okay, so typically just select your GC Code as your IDE, and then you can select different architectures. Automatically, it will select it based upon your operating system. Leave that as auto, but you can change it. If you're on a 32-bit machine, it will still work. And in terms of modern and legacy, legacy will take you into the old SynWrite, and it will just replicate the older system, but you still get the management of GCStudio, which means you get your system updates automatically, etc. And so what the update channel does, if you have it when it's selected to mainstream, you will get the mainstream updates. They'll come through, and they'll just arrive in your system automatically. It is fantastic. What else you can do in here, you can actually edit the preferences, which we saw in the first video. So if we press that, it will take us through to the preferences tool. And here it is. We've seen that before. I'll just reset the size there so we can see it. It's full screen for some reason. There we go. You've seen this before. It's a great tool, and you have to use it sometimes, but that's a quick way of getting there. Back to my desktop. You can reset the whole of the programmers if you need to. You can clone the PicKit Plus software, and that's quite good for importing it. Reset the whole of GCStudio back to the factory settings. You can create a debug file. You might need to do that if we ask you to. You can force an update so that you get a rebuild of of the system. And then you can export the GC code settings to Visual Studio. And I'll show you how to do that in a completely different set of videos. Please, I'm not going to get confused. So lots can be done in the settings. So go back, and I'm going to open up our project folder. So our project folder is called 18F. Maybe it should be called something else, don't really know. But we've actually opened it up, and we're in our files, in our IDE. On the left-hand side, we've got all the files, and we're going to be using 050 show A to D value on the LEDs. Click that. Remember that if it's in italics, you're actually just viewing it. You haven't changed it or anything. So the moment I change it, it goes solid because I've made a change to the file. Control B, or you can just double click the top left-hand corner to get rid of all the files. Look. And so this is where we are. We've seen all this before. Anything in green is comments. Seen this before. 18F46Q35 will tell the compiler to use the fastest frequency, and we'll have to define our variables. We've seen these. We define a set of constants, and then we set the LED constants to outputs. So we've seen all that before. So what's different? Well, what's different is we're going to define a value, define a variable called ADC val, and we're going to put our ADC read into that. And here's the code. lots of different options here. Let me just show you. Look, in the IDE, if you move to the left, you can compress the code. Look, you can minimize code layouts. So that's the whole of the file, top to bottom. Look. And so these loops that you'll be creating, you can minimize them by selecting this button here. So I've given you two methods in here. We're going to look at this method, and it's exactly as we said inside of the PowerPoint. So ReadAD, that is the actual command, is ReadAD, and a port called ANO, AN0, AN1, AN2, etc., etc. Where do I get those from? These are the names of the analog ports in the chip. How do I find those? Because that sounds like it's going to be confusing. I'll show you the quickest way I do it. Press function key F4 to bring up the menu and type in PIC PIC-info. This is a utility that you can use to understand so much around this chip. I'm going to zoom in on that so we can see it. Move it into screen. There we go. So what we've got here, I can type in at the search the specific chip that I'm using, 18F-46Q35. And it hasn't found it because I haven't imported it yet. I'll sort that out later. The quickest way then would be to go to Google and type in PIC18F-46Q35. I will sort out the PIC info for you later on. Go to the microchip web page and then go to documentation, but you can just open the PDF. Now in PIC info you get direct to, it will open this automatically, and that's why it has value. Let's look at the chip itself. We're going to have to go down to a diagram. This is the specification. There's a table in here somewhere of capabilities. Oh, here we go. Look, A to D converter. We're going to be using RAZ0. The name is ANA0. Okay, ANA0. And they all have different numbers, so that's what we should be using, not what I've got in my code. So let me just change that there. Let me change all instances of that. Control H will actually do a replace all. It's found one instant, which is fantastic. Okay, so we're going to read ANA0, and we're going to put the result of that in AD value, and then here is our test. So this is an if statement. You can have if then, single line, if then, end if, which is a logic statement, if then, else if then, end if. And so this is a multiple if statement. If a value is less than 50, do something else. It's between two values, do something else. Else, between two values, do something different. And it carries on, and at the bottom there'll be an end if. Perfect. So it looks quite clever, looks quite good, and we can sort of minimize all this lot. Very simple. So what are we doing? We'll just take a random one and say, so if it's between 149 and 200, which is what the flow diagram said, set 3 LEDs on. LED 0, LED 1, 2 to on, which is set to a value of 1, and LED 3 to 0. So let's just see where we are. We've got some LEDs running. This is my pen. This is where we left it yesterday. Did we leave it here yesterday? Yeah, we did. That's where we left it yesterday. And I am going to press function key F4 in here. Now, what is important is I've made some changes. We've got a little dot at the top here. Look, a little dot that says we've got changes in the file. When I press function key F4, and I say make hex and flash, which is the second option down, or function key F5, or press a little icon, it will automatically save the file for you. It compiles the file. It programs it. Got a screwdriver in my hand, so raising the part, and it's completed. We can see 2 LEDs are set. Let's zoom in on that. Let's zoom in on that, huh? Yeah. Isn't it great, computers? One moment, I'll just get the live camera back up. There we go. Here we go. Let me just bring in my tatty screwdriver. Here's my tatty screwdriver. 2 LEDs, 4 LEDs, and as I rotate the potentiometer, 1 LED, 2 LEDs, 3 LEDs, 4 LEDs on. Look, that is showing that ADC value is being represented by the 4 LEDs. Look at that, ADC to LEDs, look, clever stuff. But what we've seen in the code is that we've seen logic statements. We've seen a do loop at the end, so it continually does it, and a very simple ReadAD here. It's extremely simple. So I gave you 2 methods. What's in the other method? I'll show you very quickly. Let me just minimize that. This is the whole of that statement, look. I can mark it, and then I can comment it out. I can use various different methods to comment it out, but a really quick method is to /* at the end of the if statement, down here, */, and that's a way of commenting out a block. It's a block comment, and you'll find the same thing inside the edit. It says edit block comment, or toggle block comment. So we'll use that method as well, just to show you. I'll just block comment, Shift Alt A, and it automatically puts it in there for you. Really quite clever. Let's look at this one method here. Here's another method. Select case. Now, these have all got comments in front of them, so I can mark the whole lot, look. And then Shift / will just get rid of all the comments. Really simple. Let's look at this. This is a case statement. What on earth is a case statement? Well, we have a value called ADC value, and we can do select case that value. That variable could be a word or long, but we're using a byte. And if the case, it's a bit like an if, case somewhere between 2 values, 0 to 49, turn the LEDs off. If the case is between 50 and 99, put 1 LED on, etc., and else, case else, put all 4 on. Let's program that. Function key F5, it's compiled successfully. We'll look on the big camera. I've just taught you programming has been done. So why aren't we seeing anything in here? It's because the LED is turned off, I guess. The potentiometer is turned down. Oh, you can't see. You get the same output. We'll have a quick look at something. So it's working exactly the same. The case statement works extremely well and quite useful. So let's look at some facts here. Facts. Let's assemble that by pressing just assemble it, function key F6. It tells us a little bit of information down here. It's compiled it. So I want to know how big the program is. Function key F4. Edit preferences. We saw that before. And in here, I'm going to select the compiler tab and turn these 2 off. Verbose mode gives you a lot more information, and that's where it was normally set. Actually, I'll put it back to its normal setting of verbose. just press function key F6 just to recompile it, and we will look at the size of the program. So the program there is 179 words. That's using a case statement. Why don't we look at the if statement? So now I've gone back to the if by pressing Control Z twice. I'm back at the if statement. It's all live. Function key F6. 179 was the case. 211 is an if. So a case generates smaller code. Whilst we're here looking at the code size, I'm going to show you something at the bottom. You can optimize the reads. Now, because it's a generic ReadADC AD command, it will try to read every ADC known to man. So what I've done here, you can add in a series of defines and just say which one you want to be active, which is use AD0. I think it's also down here as AN0. There you go. Now AD0. Now, where do I get all this lots from? Well, in the IDE, I literally go __, and it's got a thing called ADC optimization, and it will add it in for you. It just added it all in for me. Then I go in and say which one I want to use. I'll type in true. That will optimize the code. And so if I take all this out, which is interesting, I'll take it all out, all these. And so these are enablers to optimize the code. So I've taken them all out. Previously, we were at 211 words, unoptimized, 392 words. So there is a benefit to using the optimization code. Let me just show you how to put it all in. __ ADC, paste it all in for you automatically. The ones that you want to set for AN and a 0 are these two. Now if we recompile, we're back to 211 words, which is absolutely spot on. So what have we seen? ADC value being shown on LEDs. Fantastic. So simple. But quite frank, really easy to use. Back to PowerPoint. So what are we going to do next? We are going to sequence the LEDs, reading the ADC, using a delay, using some scaling, put them on the put that on the ADC. I think we might even be looking at serial then. I'm not sure. I'd have to, when we get there, we'll get there. Sequence the LEDs using a delay, fantastic, from the ADC. So enjoy.